Caroline, why didn't you come yesterday? You were out? Okay.
Yeah.
You gotta watch the recording, Caroline, and please stop missing the classes. It's not cool.
Yes.
Alright, now. So today we are going to basically draw voltage versus time graph with respect to the position of the coil of an AC generator. That's a requirement, you should always remember that. Okay, so first of all we're going to make a big field. So let's suppose this is the field. And this is north and this is south, of course, like that. So when the coil I'm going to trying to make a 3D figure. So when the coil is like this, where theta is 0, the angle is 0 with respect to the field, and there could be one more position like this. When the coil is like this, then when the theta is 90 degrees, like that, okay. And then it could be on the other side. So let's suppose this is A, this is B, it's rotating like this. Now this is A, this is B, and now it could go like this. Okay, I messed up. Anyway, this is B and this is A now. Again, the angle is like 180 degrees. And now it's like this again. But this time it is A here and B here. And the angle is like 270 degrees, something like that. And so on, right? So what I want you guys to understand is that when you draw a graph, that how voltage is induced, so at this very point, the first one, the graph is going to be 0, because here we need to understand that although like the field is like passing through it, oh my god, field is passing through it, but it's not passing through the coil, so it's going to be 0 at this point. So let's say this is X, this position is Y, this is okay, WXY, we can keep it like that, W, X, Y and Z. So at position W it will be 0, at position X it is going to be maximum. Again, at position Y it is going to be minimum, and position this one Z, so this is Y, and Z it is going to be like that, and then it will continue to be like this. Okay, so the idea is that this is the next position where it becomes 360, that when the lines are cutting through the wire like this, as you can see from position Z and position X, that's when the voltage, which is, we are looking at the EMF here, is maximum. and because it's like changing, like the whole thing, like B was here initially and then now A is here, so it has moved. That change with the current is opposing, that's why the direction of the current changes, right? So it was positive first and then it's negative. That is why this will generate an alternating current. Is that clear, everyone?
Yes, sir.
Okay. Okay, so this is basically how it's done, and now, of course, we can. I've actually written it how to make like factors that increase it, so that's fine. So this is basically all we need to know about the AC generator and how it works. From this point onwards, we're going to move towards the transformer. So let's do that, okay? I hope you guys have copied this. Okay. Alright, now, whose iPhone? Okay. So the next thing is a transformer, and let's draw the design first. So in a transformer we have a core, a soft iron core, and then on one side of the transformer we have a coil like a solenoid, that basically is connected to an AC supply. So let's call this the primary coil, and the voltage it's receiving is, let's say, VP, and the number of turns here are NP. Now on the other side there's also a coil, and these two coils are not connected with each other at all, and now that's connected with maybe a voltmeter or some supply. All right, this is the secondary coil, and the voltage it gets is Vs, and number of turns are Ns, like that. The current in this one is IP and the current in this one is IS, so we will remember that. Now let me just label few other things. Now the use of iron core is iron concentrates the magnetic field generated by the primary coil. That's a function of iron. That's what we do as a core. Okay. Now, so the transformer main function is to transform the magnitude of voltage. Right, so it can basically increase or decrease the magnitude of voltage. Now, how does it work? So the question is, how does a transformer work? Okay. So what happens is, now please write the points because it can come as a long question as well. So the first thing it does is, you're going to write the primary current IP generates a magnetic field within the core of the transformer. So suppose that here the current is going in this way in the first instance. So the magnetic field is going to be like, the start, it will be produced in this and then it will start moving like this within the core because iron concentrates it within itself. Okay. Now, as the magnetic field reaches the secondary coil, so it causes a change in magnetic flux. Alright, because now there was no magnetic field in the start, but now there's a magnetic field. Alright. Now, the current slash EMF is induced in the secondary coil such that to oppose this change. Alright, we have already learned the Lenz's law. Now, the alternating current in primary coil keeps on changing the direction of the current, so does the direction of magnetic field in the coil, which means that basically, you can write it down once I've done this. Because it is AC, so every single time, like after every now and then, it will change the direction, and now the field, instead of going this way, it will go this way. And now, of course, the direction in this will also change, right? So there's constantly like changing flux. So the secondary coil constantly experiences a rate of change of flux. Hence, AC voltage is generated in secondary coil. Do you guys understand that?
Yes, sir.
Okay, you can write this, please. Now, all right. So then we need to understand that the main function is not like this is how it works, but what is the main function? Let's write that. So according to that, there are two kinds of transformers. So first of all, you write types of transformers. The first one is called the step up transformer, and the second one is the step down